Hey, welcome back. So right now on the left, you can see where we left off in the last video. And on the right, you can see what our objective is. Here, what we want to work on is on the logic behind determining the card type. And this is going to be based on the card number. I have found this easy to understand code sample that we can use to write our logic in Pega. So I will be sharing the link to this website on the description, but this code is to know what kind of card type we have based on the card number. So what I have done is I have removed all of the card types that we don't care about right now, and I have changed this code to be in Python so that I think it is easier to read. So there are four card types: American Express, Discover, MasterCard, and Visa. And there are two main rules: the card's number's prefix and its length. Here, the way that we can recognize the type of card is by following these steps. First, we need to make sure that the card number is numeric, no letters or special characters allowed. Second, there are specific lengths that each card type has. So here, we retrieve the length of the card number and the first two digits. Then, if the length is equal to 15, we go one level deeper to check if the prefix is 34 or 37. If it is, we know we are dealing with an American Express card. But if we have made it this far and the prefix doesn't match, then we return an unknown value. Now, if the length is 16, we have more prefixes to check. If the first four digits are 6011, then it's a Discover. If the first two digits are between 51 and 55, we've got a MasterCard. And if the first digit is 4, then it is a Visa. Once again, if we have made it this far without a match, then we return an unknown value. Lastly, if the length is 13 and it starts with 4, then it is a Visa. If nothing match, then we return an unknown. So I think this is a very basic logic to determine the card type. So we have already seen how decision tables work in Pega. Now it's time to learn about decision trees. So both decision tables and decision trees evaluate conditions to return results in Pega. So for decision tables, we evaluate multiple combinations of the same set of properties. Each column compares values against a fixed property and operator pairs. They are best for structural evaluations that are based on predefined criteria. Then decision trees evaluate different properties depending on certain conditions. So each branch checks a property and operator pair against a value, and this may trigger an action or a further evaluation. They are ideal for scenarios where conditions depend on previous outcomes. So for this current scenario, I believe that the best option is to implement a decision tree. This is because we have to evaluate different aspects of the property. So even though we are evaluating the same property, which is card number, we are actually evaluating different aspects of that certain property. So the first digit, the first two digits, the first four digits, and the length. Another reason for using a decision tree is that we have nested evaluations. So first we check the length and then we check the prefix of the card number. And not to say that the decision table is not able to do this, but it wouldn't be ideal because it evaluates multiple conditions against the same property. Whereas here, we check different properties, the length and the first digits, and also using a decision table will lead to many empty columns because of the varying condition types. So here, as you can see, this is the result of using a decision table for this scenario. We have many columns and we have rows indicating the hierarchy of conditions in the order that we are checking. So within each column header, we have certain conditions that we are checking. So the first thing that we check is that we have a numeric card number. If it's false, then we return unknown. Then we check the length. We check if it's 15, if it's 16, or if it's 13 digits. Then we'll check the substring of the card number, the first two digits. And we check if it's 34 or 37 to know if it's American Express. Then we have a second column where we are also checking the prefix, but in this case of an integer, because we want to know if it's within a certain range, so 51 or 55. Then, if that's not the case, we continue and we check if the substring of the first four digits is 6011. If that's the case, then we have our discover. And lastly, in the last column, we check if it starts with 4. So here we are checking the length. If it's 16 and starts with 4, we know that it's Visa. Or if it's 13 and starts with 4, then we know that it is Visa as well. And lastly, if none of these conditions evaluate to true, then we know that it is unknown. So as you can see here, we have many empty boxes in our decision table. Now, if we do this with a decision tree, it will look something more directed towards a resolution. So here you can see how there are the two difference between using decision tables and decision trees. Personally, I think that for this case, the best approach is using a decision tree because it's way more directed towards the intended resolution than using a decision table and having to add new columns for each thing that we want to check. So imagine in the future, if we want to check the prefix of 3, we will have to add a new column. And maybe we also want to check, I don't know, a new length. So we will have to add new rows and new columns for each new thing that we want to check. And in contrast, in the decision tree, I think it's more maintainable and it's a bit more readable than the decision table. Okay, so let's get started. So the first thing that I'm going to do is to make a declare expression for the card type. So let's go to our data layer, and on billing information, we are going to create a new declare expression for card type. Here I'm going to select decision tree, and I'm going to create my decision tree. So as you can see, this is a very basic configuration that we have to do. Now, if we want to modify the first condition, we can do it here. And as you can see, the only the only function that we are able to use here is this comparison function, where we compare one property to another property or value. And we have these operators here. But what I want to enable is the freeform expression so that we can use many more functions that Pega provides out of the box. And to do that, we have to go to the configuration tab. And here we are going to allow changes to function list. So with this, we can already use all of the functions that we want. In this case, the only functions that I want is the freeform expression boolean. So I'm going to select both of those. I'm going to save. And now I'm going to go back to decision. And from here, you will see that we have the option to use this expression evaluates to true. And here we can add any type of logic that we want to evaluate. So the first thing that we want to do, let me bring my code. So here, the first thing that we want to check is if the card number is numeric. So here, this function returns a boolean, which is true or false, and evaluates a string and checks if it only contains digits. So I'm going to be using this one. And the one that I'm going to evaluate is card number. So if this is false, then I want to return unknown. Then let's add a second one. And here we are going to start working with the length. So we want to check the length if it's 15, then if it's 16, and then if it's 13. Okay, now what we want to do is to check the prefix for all of these lengths. So let's start with the length of 15. We want to check if the prefix in integer form is 34 or 37. So to add a child to continue checking certain conditions, or a branch, I should say, you have to select continue instead of return. So here, what I want to have to retrieve first is so actually here in Pega, what I'm just going to do is to retrieve the, the first two digits as a string form. I don't need to convert them to integer. This function returns a string. So you have to provide a string, then you want to indicate from which index you want to start cutting and in which index you want to stop. So this will return a substring of your initial string. So the first parameter is the card number, or the string that you want to cut. Then you want to indicate where you want to begin and where you want to end. So you can test. So if I enter 1, 2, 3, 4, I should have 1 and 2 over here. Yes. Then here you want to check if it's 34, and also you want to check if it's 37. Or if it's 37, my bad. If that's the case, then we have an American expression. Then let's continue with when the length is 16. Here we will have two branches. One to check the first four digits, another one to check if the first two digits are between 51 and 55, and lastly to check the first digit if it's 4. So here, this is returning a string, but I want to check if it's greater than 51 or lower than 55. And for this, we need to convert this string to an integer. So I know that we have this function that is called toInt in Pega. It takes a string and returns an integer. And lastly, we want to check if it starts the prefix, the first digit with 4. And if nothing of this evaluates to true, then we are going to return unknown. Okay, let's try some conditions. Let's start with American Express. Okay, that works. Now let's try Discover. Okay, it works. Now let's try MasterCard. Okay, that works. And let's try Visa now. Yeah, it seems to be working. So that's everything that I have for you today. In the next one, we will start working on evaluating this page property in our case type. See you in the next one. Thanks.